All right, welcome to today's class. Today's class is actually Indices Part 9. Indices Part 9. And you may be wondering, why is it up to Part 9? As far as indices is concerned, it is not a topic that I can treat in only one video. It is not a topic that I can treat in only one video. And so that's why I'm breaking it down into different parts, or you can say different sessions. It is not a topic that I can treat under one video. So that's why I keep advising, if you come across any of my video and it is not part one, please try and go through part one before going through that particular video you came across. For example, if you are just coming across my video for the first time and this is Indices Part 9, you may not really understand it except you go through part one first, because each part is actually a continuation. They are all linked up together. So, especially in part one, for every video that I do and it is part one, it is always the introduction of that topic. So, for example, under indices part one, I took time to explain the laws of indices and then before solving any example. So, indices part 9, we have two examples on the board. The first one is, if x raised to the power of 3 over 4 times this is equal to x raised to the power m times y raised to the power n. Find the value of n raised to the power m. So I'll go straight by solving. This is x raised to the power of 3 over 4. Still from our knowledge of indices, that's why I said try and go through part 1 before coming over to part 9. There is a law of indices that says that if you have x raised to power 1 over n, it is simply the end root of x. So the square root of y over x is the same thing as y over x raised to power 1 over 2. The square root, n root of x is the same thing as x raised to power 1 over n. So the square root, when we say square root, there is 2 here, but we don't always write it. When you say square root, there is 2, but we don't always put it. So, and then over to the next one, that is times y raised to the power of 5 over 8, and then that's equal to, all right. Let's continue from this other side. This will give us x raised to power 3 over 4 times, still from our knowledge of indices, if you have x raised to the power of, where is it? If you have x over y raised to power n, it is the same thing as x to power n over y to power n. So for that reason, this can be expressed as y raised to power 1 over 2 over x raised to power 1 over 2. Then, of course, times y raised to power 5 over 8. And that is equal to x raised to power m, y raised to power n. Still from indices, you can write it as x raised to power 3 over 4 divided by x raised to power 1 over 2 times y raised to power 1 over 2 times y raised to power 5 over 8 is equal to x raised to power m, y raised to power n. Now, let me continue from here. Under laws of indices, when it is division, when the bases are the same and it is division, you subtract their powers. When the bases are the same and it is multiplication, you add their powers. So the base here is x, the base here is x, and it is division. We subtract their powers. That will give us x raised to the power of 3 over 4 minus 1 over 2. That's for x. Then y raised to the power of 1 over 2 plus because the bases are the same and it is multiplication, we add their powers. And that is equal to x raised to power m, y raised to power n. Okay, 3 over 4 minus 1 over 2. We can solve that. 3 over 4 minus 1 over 2. The LCM is 4. So 4 divided by 4 is 1. 1 times 3 is 3. You bring down the subtraction sign. 4 divided by 2 is 2. 2 times 1 is 2. And that gives us 1 over 4. Which means that this is x raised to power 1 over 4. Now over to y, do the same thing. 1 over 2 plus 5 over 8. 1 over 2, 1 over 2 plus 5 over 8. The LCM is 8. 8 divided by 2 is 4. 4 times 1 is 4. Bring down the addition sign. 8 divided by 8 is 1. 1 times 5 is 5. And that gives us 9 over 8. And so this is raised to power 9 over 8. And that's equal to x raised to power m, y raised to power n. So at this point, we can compare the left-hand side and the right-hand side. So if you compare the left-hand side and the right-hand side, you see that therefore m is equal to 1 over 4. Yes. And then y is equal to 9 over 8. And we were asked to find the value of n raised to power n, which therefore means that this will be 9 over 8 raised to the power of 1 over 4. That's the answer to that question. That's the answer to that question. If it is a theory question, if you leave it like that, you are okay. But in objective, there are many ways of keeping the answer. There are many ways. In objective, you can still keep it like this. 3 raised to power 2 over 2 raised to power 3. This is still correct. You can even take power 1 over 4 inside if it is objective. Another way you can keep the answer is 3 raised to power 2 over 4, which is 1 over 2, all over 2 raised to power 3 over 4. This is still correct. So those are different ways you can keep the answer to question number 1. So quickly, let us look at question number 2. Let us look at question number 2. Question number 2. Given that 2 raised to the power of x is equal to 0.125, find the value of x. 2 raised to the power of x is equal to 0.125. This is 2 raised to the power x. 0.125 is the same thing as 125 over, where you have the decimal point, you write 1 and then zeros. 1, 2, 3. You have 3 digits after the decimal point, so that will be 3 zeros. Okay. Okay. At that point, you can decide to reduce the number to the lowest thing. You can reduce this to the lowest thing. 2 raised to the power x is equal to, you can use 25. You can even use, okay, let's start with 5. Let's start with 5. 5 goes here. 2 remaining 2 carried another here becomes 25. And 5 goes into 25. 5. 5 goes into 10. 2. Here 0, 0. So we are having 25 over 200. You can still divide it again. You can use 25 if you want to, but let's play with 5. 5 here, 5. And then 5 here, 4. And then 0. 5 again, 5 here, 1. And then 5 here, 8. So that's giving us 1 over 8. Still from our knowledge of indices, this is the same thing as saying 2 raised to the power x is equal to 8 raised to the power minus 1. Remember from our knowledge, that's why I'm saying try and go through part 1 before coming over to part 9. We have done something similar to that in part 1, laws of indices. So 2 raised to power x. 8 is the same thing as 2 raised to power 3, which means that 8 can be written as 2 raised to power 3. But take note, there's power minus 1 here, so that will make it 2 raised to power minus 3. And so the base here is 2, the base here is 2. So it implies that the power here must also be equal to the power in the right hand side. So therefore, x is equal to minus 3. And so that's the answer to question number 2. And with that, we have come to the end of this class. We have come to the end of this class. Thanks for watching, and bye for now.